Hello and welcome to another video from sickmaths.co.uk where you can find us some free maths videos. This video is about number patterns and finding the nth term. Okay, so what are number patterns? Quite obviously, they're just patterns of numbers. So 2, 4, 6 is a number pattern, 3, 6, 9 is another number pattern, even minus 2, minus 4, minus 6 is a number pattern. Okay, and what are nth terms? Nth terms are another way of saying the rule for the pattern. There's a reason why they call it the nth term. It's saying, well, if I wanted to know the third number or the third term in a pattern or the 100th term in a pattern, how would I work it out? When you say nth term, that means any term in the pattern. So it's like you could call it the rule for the pattern, the rule to work out any term in the pattern basically. So for example, the rule for 2, 4, 6, this pattern here which keeps going on, yeah? Okay, basically the 2 times table is 2n. So how does that work? Well, n is the position you are in that pattern. So let's say we're looking for the third term in the 2 times table. Okay, you just replace the n with a 3, so you get 2 times 3, which gives you 6. So that's the third term in this pattern here is 6. So that's how simple it is. If I wanted to know the 100th number in this pattern here, okay, I'll replace the n, which is my position number, with 100. So I get 2 times 100, which is 200. So I've worked out the 100th number in this pattern. So that's what the nth term is all about. Okay, how do you work out the nth term? Because it seems so obvious in this first one, doesn't it? It's just 2 times table, yeah? So obviously, if it's 2 times, I want the 100th number in the 2 times table, you just do 2 times 100. It's really obvious. And in fact, it is quite obvious for a lot of them. It just looks a bit more complicated as you go on. But if you base your idea on this, it's really obvious, yeah? So it makes sense that the 2 times table should have nth term 2n, and a 3 times table should have nth term 3n. And it also makes sense, if you think about it, that if you've got something that looks like the 3 times table because it's separated by 3 each number, you know, 2 plus 3 is 5, 5 plus 3 is 8, etc. Okay, that should have 3n minus 1. Yeah, so it's like the 3 times table is just take away 1 from the 2 times table. Because look, this is the 3 times table, and this one is 1 less than that, this one is 1 less than that, 1 less than that, etc., etc. So even that one is 1 less than that. Yeah, so it's the 3 times table, just take away 1. So it should be 3n minus 1. That should be the nth term for such a pattern. And this pattern is a 2 times table with just a minus in front of it each time. It's like going downwards, isn't it? Yeah? So when a pattern is going backwards but separated by 2, it should be like the 2 times table but just minus. So minus 2n should be the nth term for such a pattern. Okay, so that's that. So as I said here, this is one example, this row. The nth term for pattern 2, 4, 6 ... going on forever, the nth term should be 2n, and the 100th term is 200. That's what this row is saying. So that's how easy that is. Sometimes you get the same idea as this, but just with actual physical patterns. So let's imagine you've got matchsticks. Oh, forget it, they're just lines, yeah? So you've got 3 lines here. You've got, how many lines in this? 1, 2, 3, 4, 5 lines there. You know, you can count all the lines. And when you count the lines, you just get back to a number pattern. Except for this one's going downwards, but who cares? So, the first number for the first pattern, I've got 3 lines, and the second pattern I've got 5 lines, third pattern I've got 7 lines. So you've got a pattern going. What's it going up by? It's going up by 2, isn't it? 3 plus 2 is 5, 5 plus 2 is 7, plus 2 is 9. Yeah? So it's like the 2 times table, but it's clearly not the 3 times. So it's like the 2 times table. I hope I said that first time. So it's like the 2 times table, but it's clearly not the 2 times table because it begins with 3. So it's the 2 times table begins with 2, and this begins with 3. So I should obviously add 1 to become this pattern. So it's 2n plus 1. Yeah. So it's a 2 times table plus 1, which is this. Now once I've got this nth term, I can work out the number of lines in the 20th pattern. All I do is do 2 times 20, because that's now the position you are in. That's the first pattern, that's the second pattern, fourth pattern. So the 20th pattern is 2 times 20 plus 1, which is 2 times 20 is 40, plus 1 is 41, which is this. Nth term 2n plus 1, 20th term is 41. So that's physical pattern, that's standard pattern, and this is n squared patterns, the only other type you have to know. N the square just means square numbers, doesn't it? Yeah, so if n is 1, n squared is going to be still 1. If n is 2, n squared is going to be 4. Yeah. So they don't make it all that complicated. Sometimes they make it a tiny bit complicated, but usually it's something very similar to n squared. So look at this, 2, 5, 10. Okay, it's only one more than all these square numbers, so it's just n squared plus 1. And how do you just generally recognize that you've got one of these n squared patterns rather than these kind of patterns? Well, these patterns are always separated by a fixed number, like, you know, we were saying it's like a times table, yeah? So this one's separated by 2, it's got common difference 2 is the word. Yeah, this one's got common difference 3, this has still got common difference 3, yeah? But these ones, the common difference are different, yeah? The difference between 1 and 4 is 3, the difference between 4 and 9 is 5, yeah? So that's how you know you've got an n squared kind of pattern. And it's never really 2n squared or 3n squared, just n squared. They just don't make it complicated in GCSE exams. So once you realize it's an n squared pattern, you compare it to n squared, and you just take away the difference and you see what you've got left. Like if it's just one more each time, you know it's n squared plus 1. Sometimes it's a bit more complicated. Let's say you've got your 2, 6, 12, then I take away my n squared pattern, which is 1, 4, 9. So take that away, and what do I get? 2 take away 1 is 1, 6 take away 4 is 2, 12 take away 9 is 3. What's this pattern? 1, 2, 3. Oh, that's just n, isn't it? Yeah, because that's just a 1 times table. Like 2 times table is 2n, 3 times table is 3n. So why not the first 1 times table? Shouldn't that just be n, right? So that is effectively this thing 2, 6, 12 is effectively the n squared plus pattern plus n pattern. So I just stick them together, n squared plus n. These two patterns together make this pattern, and that is it.